And our next speaker is Philip Cran, and he will talk about seccomp. Just welcome, Philip.
Thanks. Hi, everyone. Who has heard of seccomp before? Okay, about half the room. Good. So let's see where we can take this. So seccomp, the secure computing model, is something that has been around for quite a while, but is still not as widely used as you would wish. And generally, security-wise, often this is us, and we say everything is fine until something, whatever that is, happens, and then nothing is fine anymore, and everything is on fire, and everything is terrible. And then you always wish that you had something else to fix your security model. And seccomp might be one piece in the big puzzle of security solutions that you could use to help fix stuff. Obviously, there are no silver bullets, and there is no one tool, but you want to have like more layers and an in-depth security model. And seccomp is exactly what comes into play here. Generally, it's just one piece of least security. So it's trying to take away things that you don't actually need that might just expose you to more risk. And it basically just blocks certain system calls that you know that your applications do not need. So if you, for example, know that your process never needs to fork another process, or you never need to call another binary from your process, why not just take away the possibility from your application? So even if you have a remote code execution and somebody can run whatever they want in the context of your application, you still cannot do some stuff that's just generally not necessary for your application. And that's really just the idea of seccomp. And it's basically just instrumenting the kernel to do that for you. And it's like a sandbox to filter out stuff that you don't want. But it's application driven. It's not like generally, it's not SA Linux, for example, or AppArmor. It's really application driven because the assumption is the application developers know what their application needs, and then they can register the right profiles for the applications and then filter out all the unnecessary stuff. It was introduced like forever ago, basically. It had the so-called strict mode. The good thing was strict mode was very strict, but the bad thing was also that strict mode was very strict. Like with these permissions, you can barely do anything. Yes, you can read and write a file, but there is no network access at all. You cannot even change the system time. Like nothing can be touched here basically except these 4 system calls. And that was a good first step, but it was way too restrictive for the average application to be actually useful. So it had to kind of develop over time. And a couple of years later, the foundation was added for system call control. And in 2014, seccomp was actually added to make that configuration easier. And I hope that everybody is on the kernel version that supports that. But that's a different story. Anyway, so you can generally, I guess everybody knows man syscall, so you can see what system calls does your kernel version support. And by the way, there are new ones being added over time, and you can see that in syscall as well, which ones have been around for how long. And then with seccomp, you can basically see how you can filter those and not allow specific system calls. And the way you write that is BPF, the Berkeley packet format. Where do you normally use BPF? Probably TCP dump when you do that. When you're pretty desperate and you try to find something on the network interface, that's one of the places where you might use BPF. And those are not the most human-friendly ways to write anything, but you maybe get used to writing BPF at some point. So the minimal setup would be, for example, here, we need these 2 header files, and then here at the end, you basically have a structure where you register the system calls that you want to allow, for example, or deny. And it could look something like this, and this is pretty small. The most important parts are, first, you want to check the architecture, because different architectures, different system call numbers, which can add confusion, and you might allow the wrong ones then. Here we basically check which system call is coming in, and then you decide, do you allow that? So here we're basically having an allow list, like everything we allow will pass through, and everything not on the allow list will then run into the kill process and just shoot down your process. Every call that you do once you have system call seccomp enabled will then run through that. The question that sometimes comes up, is it very kind of expensive because it's for every system call, not really because it runs in the kernel, so you don't have to go to user space for all the calls. So it is pretty cheap to actually run those. The results that you can have is a call can be allowed. That's probably the good case. A thread or a process can be killed. You can also return an error and log any problems if you run into those. Is anybody using seccomp? Like, are any of the applications that you're using on a daily basis, are they using seccomp? Probably yes. Some of the more widely used ones are these here. So you probably touch seccomp somewhere every day. Especially Docker has used seccomp quite a bit. And if that hasn't been changed in the meantime, 44 system calls out of 300 plus are being filtered. And that used to be quite a lot of manual work for them to figure out what you can block and what you cannot block. But they found a more or less secure setup of what can be blocked out by seccomp. So for example, some stuff that they are blocking is you cannot change the system time because that's not namespace. Time is global on the system, so you cannot change that from within a container. You cannot clone a namespace. You cannot reboot the host. You cannot unshare or copy a namespace either. So these are system calls that are blocked. And you can also check that out. So for example, what you can do, which is obviously not recommended, but you can kind of like disable the seccomp filter on Docker, and then you can just clone a namespace and then see that you're running here as root. If you use the default settings, then this would not be allowed because unshare has just been disabled. So this is where Docker uses seccomp, for example. Is any of your applications using it? You can also filter that out if you look at proc whatever status, and that number tells you 0 means no, 1 means the strict filter, which is probably too strict and nobody's really using that anymore. So you will probably not have any processes with 1, but the ones using seccomp will have a 2 there, and that's how to identify which processes have actually registered a seccomp filter for you, and which ones have not and probably should. And then you can just check out the process from there and see what's being filtered and what not. So why am I talking about that? I work for this little company called Elastic. We have some products, and we also use seccomp heavily. If you've never seen any of our products, maybe you've seen this one, the good old elk, or we've added another component called beats, and then we kind of had to redo that elk because there is no bee in elk, and then we tried this, the belk or elk bee. And you can see it flies and everything, but anyway. So in our stack, we have 2 components that use seccomp heavily. That is first beats, which is like a lightweight agent or shipper written in Go, since that runs on pretty much all the systems where you want to collect information. And then Elasticsearch, since that stores your data and probably you want to add some extra protection there. Logstash has an open issue, and Kibana as well. They don't use seccomp yet, but Elasticsearch and Beats, for example, do that. And just to give you an idea how to do that, Elasticsearch is a Java process. How do you set seccomp filters from a Java process? JNA, Java Native Access, is the thing what you do. This would be the relevant part from the source code. First, something that is not strictly related to seccomp, but something that every process should do is this one. And people mostly accepted that you should not run processes as root, especially server processes. So we will just throw an exception if you try to run Elasticsearch as root and exit. And secondly, we will check, or we will try to register system calls there. Then, depending on your operating system, seccomp is really Linux specific, but most other operating systems have a similar concept, even though it might be called differently. And we try to register those on all the available operating systems that we support. And otherwise, just throw an error and say, we don't support that one. Yeah, different ways to do seccomp, but we'll stick to Linux, and then it's just seccomp. And this is basically what we do in Elasticsearch. So the joy of BPF at work. The main ones that you're interested in, for example, you cannot fork a process and you cannot execute another binary. So even if we had a remote code execution in Elasticsearch, which hopefully we don't, you could not fork another process or execute any binary on the system because we filter those calls out. So that just wouldn't work. Then we have beats, which are these lightweight agents, and they have basically their own syntax to filter that out in Go, or they wrote their own library because they didn't want to write BPF itself. They wanted to have YAML instead. So basically, they created something like this. Here you can see this allows all the calls by default and then filters out specific system calls. So this is basically a deny list. Is this what we're using in Beats? Actually, no, because Beats, since it's shipping data over the network, would need some network access, and this doesn't allow any network access, so this is just a sample of what we do. Actually, the real rules are many more, but we do use an allow list. So we basically have whitelisted all the actions or calls that we need. This will be a very long list, and everything else will be blocked. So every time a new system call comes out or we need a new one and we want to whitelist that one, we will need to update that list manually. But as always, allow lists are more secure than deny lists. So yeah, because new system calls and you might allow something otherwise that you don't have intended. Okay, so we could just try that out very quickly. So for example, if you run good old netcat, and then you could just open a connection and say, hello. Oops. And ideally my hello should arrive. Why is my hello not arriving right now? No, this is, netcat doesn't use seccomp, and also, but we'll get to that in a moment. Let's see. This is the wrong host, my bad. Because this is a demo and I'm already using this domain for a demo. Because, hello. And well, if you use the right one, this works. You can use it as well, it's just online, so you can start chatting. Now the main questions are, which system calls are involved here? What are we using to figure out the system calls? strace, yes. So we can just run this with strace. Oops, trace. And that will show us a ton of system calls that will be needed here. The most important one is at the end when, okay, I think somebody said yay here. And that then killed with a bad file descriptor my process. But you can see all the calls that we are doing here. And that is, by the way, one thing that is kind of relevant. So yeah, if you run strace and, for example, with -e bind, you can just filter down on the bind action because that's the one I want to monitor here. So you could just see this is just a system call for the binding. That's how to monitor that. And if you leave that out, you see a lot of system calls. And this is, by the way, a good way to figure out which system calls does my binary even need? What do I need to whitelist to allow my binary to work as expected? The other way to figure out which system calls do you need to allow for a binary to write the right seccomp filter is there is, under this address, you can find a little C utility which you can add, which will then collect all the system calls that you're doing. Otherwise, you can always use the strace output and just grab the system call, which is always the first thing in every line. And you could just aggregate those and then figure out what you need to allow or what you can deny. And then you can simulate what would happen if you would deny a certain system call. And for that, there is a little tool called FireJail that can basically run or deny specific system calls. And you can run it like this, and let me paste it in. I think I've copied that because nobody wants to see me type that. So we have FireJail without the profile. We drop the bind permission, and then we just run strace on my binary, and I try to bind to port 1025 again, and then it just tells me, well, my system was called, my process was killed because you can see I tried to open a socket, I then try to do the bind, and exactly then does FireJail kill my process just as expected. So this is not allowed here. And Yeah, that's the output you will get here. One thing that is sometimes interesting is what happens if somebody takes over your binary and then tries to change the filters. Any guesses what will happen? Will it, you can only, well, I'll give you 3 options, and you can decide what you think is most likely. First, you can only set seccomp once. Second, you can drop the permissions to change anything in seccomp. And third, YOLO. The third? No, it's not YOLO. So what you need to do is, when you set up seccomp, the first thing you want to set is set no new privileges. This basically means you can always tighten down over the life cycle of an application. You can always tighten down the rules, but you can never loosen them up. So once you've taken away some permission, you cannot add it anymore. So even if somebody takes over your binary, they cannot then allow a fork or execute or whatever, because you can only tighten it down. So this is the first thing that you should set to make this secure. Are we doing that? And I was kind of curious how we were setting that up. Yes, we are. So for example, here you can see the system call since Linux 3.5 for set no new privileges is 38. Then we try to set this one here, and afterwards we actually check. And if setting that permission or that filter did not succeed, we would actually error out on the process. So we ensure that this has worked and you cannot change the permissions afterwards. Beats has, since it has this YAML syntax, just has this no new privs true, and you're done, which is maybe a bit more readable, but the binary in the back, or the library in the background that does all the YAML parsing does just the same with VPF to set the right filters. And then you probably want to figure out that somebody has kind of like caused some seccomp violation. So auditd, the Linux auditing framework, can also collect those. We have another component in our stack called auditbeat, which can collect any violation of those. And then you can just collect those and see where it's going. So for example, if you then look in Kibana, you could just say like, give me all the violated seccomp policy actions, and then you would see these were all the kind of like things where you violated the policy. And then you would also see like which user, which binary, which system where that happened, and then you can try to find out like, do I need to change my rules, or did somebody break in and try to run some filters or system calls that they were not allowed to run. We also have this new seam component, which is more drag and drop oriented, and then you could drop that in here. And this shows you, this was when I was trying that with netcat, and you could see, for example, the Ubuntu user on the what the fuck host was trying to use netcat, and that was actually a violation, and I filtered that out here. And then you would know like which binary is affected, which user might be affected, and you could filter those down. So to wrap up, it's always kind of Lego security. So there is not just one block that you need to put in, but there are many blocks that you need to combine to have better security, and seccomp is just one of these little building blocks. Sometimes people ask, like, how does it compare to SE Linux or AppArmor? One is, or both of them are, or all the approaches are kernel level filters or interceptors. The main difference is that seccomp is where the process actively sets that, and basically the application developer rolls it out with its application, versus setting it mandatorily before the application is even being started, which is what SE Linux and AppArmor are doing. So it is widely available. Hopefully all your kernel versions support that. You can use seccomp and hopefully have more secure applications. If you want to write that more easily from your own application code, there is a library called libseccomp, and they have a lot of samples of how to write the filters from various applications. So that might also make your life a bit easier to apply seccomp in your applications. And then people always ask me about Windows, and I haven't used Windows in years. But I Googled, and this seems to be the most similar system call filter that Windows has. And it has, I guess everything is as terrible as the name is there, but this is what you get. And if Windows is your thing, look into it, but I have no idea how it works. And I don't really intend to look into it too much. But this is the closest equivalent that I could find. And that's pretty much it. I think we're right on time. for a couple of minute questions. If you want stickers, grab the stickers afterwards. Wait for the microphone so everybody can hear the questions. By the way, before we do the question, I always try to take a picture with you so I can prove to my colleagues that I've been working. Because we're a fully distributed company and nobody knows where I am today. Can you all wave? Very good, thank you. Question?
Yeah, so I was waiting till and wondering why you didn't mention the sleep seccomp, and it was just on the last slide. So the question would be, why aren't you using it actually? Because as you mentioned, doing that work manually is quite hard. You have to have those defines when, which kernel version, which architecture, all that stuff. And the sleep seccomp is actually doing that for you and making those ugly defines macros not necessary and all that stuff, right? And also gives you a much easier way if you not, because thing you also I think not mentioned, that you not only can filter which system calls can be used or not, but you can also check the arguments. So for example, you can only allow certain syscalls if the arguments are right. Like you can allow read or write or open on only on some file descriptors or things like that. So the main question is, why aren't you using it if it's there and you know about it?
To be honest, I don't know, because I've only been with the company for 4 years, and it has been there before me. So I kind of don't know the history why we started on our own path without libseccomp. I will try to find out. It's actually a good point. I don't know why maybe we just didn't know about it. I don't know, but it was a long time ago. So, yeah, hi.
Hi, great talk, thank you. In Docker, there is when you look at syscalls, there is a seccomp that is involved and also capabilities. And I was wondering, could you please describe how they both fit with each other? Like, is Docker generating a seccomp policy relative to which capabilities are enabled? Or like, I feel like there's two moving parts that I don't know how fit together.
Yeah, with the capabilities you mean the like net admin whatever when you
yeah,
can
for
change
example,
something
there's
on
a capsys ptrace that controls the ptrace syscall, but you can also block it in seccomp.
Yes, I don't know how they join together, but yeah, you can override basically the seccomp filter with that setting. And you always set, so I know that, for example, if you want to run a container that monitors the network calls from other containers, you need to set that net admin, and that must override the filter, because otherwise you wouldn't get to those. But how that's implemented in the background, I haven't checked the source code of Docker for that.
Okay, thank you.